Hi, everyone. My name is Abby Bangser, and I'm super excited to share with you my experiences with chaos engineering in a mature organization. I currently work as a test engineer on the platform engineering team at Moo, where we print custom designed goods like business cards and other paper. So it's really fun to work in an organization where we have a physical product as well. And that's part of where this becomes fun. So looking forward to sharing our experiences with you. So let's get started by making sure everyone's on the same page with what chaos engineering is. So if we start with the definition from Wikipedia, it is the discipline of experimenting on a software system in production in order to build confidence in the system's capability to withstand turbulent and unexpected conditions. The only place in this definition that people tend to have a disagreement is on if it needs to be in production. This is a key part of the definition because the only place you can gain confidence with your production environment is in production. But that doesn't mean that chaos engineering has to be limited to production. So I don't want to get too caught up on whether or not this can only occur in production or other environments, because actually a lot of the Moo experience is in staging and in pre-production environments. But so if we take this definition and we focus in on it being a discipline of experimenting, we start to see a contrast with how a lot of people talk about chaos engineering based on what comes out of Netflix and our experiences of learning from them. And here's an example of a quote about Netflix, not by them. They talk about Netflix proactively causing failures in random places at random intervals throughout the system. And this makes it sound quite scary, quite uncontrollable. And that is very true around what Netflix does today. They've already tested their systems for being able to handle certain kinds of failures. And now they inject those failures on a regular basis, both at random and in random locations, to make sure that they continue to be able to handle those failures. But you don't, again, have to start that way. You start through deliberate experimentation. So instead of this kind of menacing looking chaos monkey, what it can really mean is actually more of an experimentation, a scientific method. And you're seeing that in a lot of the chaos platforms that are coming out today. Here's a screenshot from Chaos IQ, but depending on the platform, they may use different terms, but they all are talking about identification of what can go wrong, what the blast radius of that fault injection would be, how to revert back if anything went wrong with the experiment, as well as why you even want to run it. We're not just running technology experiments because it's fun. We're doing it to mitigate risks. So we need to think about what those risks are up front. But given this kind of divergence in definition from the official definition to the more randomness, which has become commonplace vocabulary today, I want to take a look at what happens when you really only focus on the chaos part of chaos engineering. And I'm going to do this through a story about our work at Moo. And so at Moo, we started our journey with chaos engineering, Chaos Monkey, back in 2017. And it was the introduction of this Google Calendar invite for 35 weeks between July of 2017 and May of 2018. And while this Chaos Monkey operated for 35 weeks, it disappeared for a few months and came back without the term Chaos Monkey, which is quite an interesting experience. But let's look through a little bit more detail of what happened during that 35 weeks and try and dig into how successful or challenging our experience was. So we kicked off in July 2017 because that's when we made a transition from our data center to the cloud. And it was a completely successful transformation, and we moved all of our production traffic into the cloud in July of 2017. And that was fantastic. And so to get to the cloud, our team had started to experiment with the different cloud technologies, with auto-scaling groups and how those worked. And they wanted to keep that going. And so they introduced Chaos Monkey as an automated tool to try and kill servers once in a while in order to train our software devs that servers can die in production, and we need to be prepared for it. By September, though, these weekly events of exploration of identifying new possible failures started to get canceled. War games is a term that's used to indicate that we're trying to imitate production outages, unknown unknowns, and see how our people and processes and our technologies uphold during that time. And so we had done these every week starting in July. And now all of a sudden, our platform engineers are starting to get less value from these experiences because they're busy with real outages and they've gained enough experience in the cloud now that they feel like, why do I need to practice anymore? So they start getting canceled here and there. Later, all of Q4, we're also getting a lot of conversation from our software devs. They hadn't been involved in these chaos experiments and in these war games week to week, and they were starting to assume that failures in the staging environment where Chaos Monkey was running were just problems, were flakiness. And anyone who's ever worked with test automation knows that's the death of a test automation suite, when people start ignoring failures because they assume flakiness. As a part of ignoring these failures, they also were starting to deprioritize the fixes associated with found issues. This is part of just not really understanding that while the Chaos Monkey might have been what triggered the outage in staging, it wasn't just a made up failure, that it's based on a very real possibility for your production environment that a cloud instance goes away. And then I did a bit of hunting and I couldn't find really any conversation about Chaos Monkey or chaos engineering after December 2017 for a few months. I say I did some hunting because I actually wasn't at the company yet at this point. And so I went and I talked with people and I looked through Slack and it just was quiet. There wasn't a lot of conversation on the topic. That is until July. So 6 months later, we have a request and a merge request to put the entire Simian army out into all environments, including production. And Simian Army is an open source tool by Netflix, which includes Chaos Monkey, but also a lot of other automated tools which allow for you to inject faults in different ways throughout your system. And this was now being rolled out to all of our environments because we hoped that we would be able to run more chaos in production and not just in staging anymore. It was a great idea, but then around November, it just kind of stopped working. No one was really paying attention to this anymore because we never got buy-in from leadership or other software teams to continue to run Chaos Monkey with automation in staging at a larger scale, let alone in production. And so it wasn't until March that we noticed actually that monkey we had set up to kill some instances once in a while wasn't even doing that anymore in staging. So now we're in trouble. And it sparked a lot of conversation about what chaos engineering meant to us and what we wanted to do about Simian Army and the Chaos Monkey. A month later, we decided, you know what? We want to make sure we're doing this the right way. We really don't have buy-in across the organization right now. We don't really have a vision for this. It's important we do it right. And so we're actually going to remove Simian Army from our technology until we decide how we're going to put it to use better. And I think this is a super common experience of trying something new and seeing that in the end, the uptake isn't quite there. So verdict time on our experience at Moo. Was this a success? Was this how chaos engineering can be introduced to new organizations, particularly ones that already have user bases that they're scared to impact negatively? Well, I'm sorry, I used to be a consultant and it's still in my genes. I have to say it depends. But the best part about this, it depends, is that it's actually based on concrete criteria and on whether or not it was a success. And that's what I'm going to spend the rest of this time chatting to you about. And the reason I think this is important is because there's actually, in my opinion, 3 ways in which chaos engineering can support you and your organization. It can support your people, your process, and your platform. So by focusing in first on people, it's important to remember that with people, perception isn't always reality. And in many cases, it's usually not. And so by introducing chaos scenarios, for example, in something like a war games or what we now call game days, you give people the chance to identify what they need help with, the opportunity to share their knowledge with teammates who need help in areas they're successful at, And also, you give people the chance to self-evaluate on their readiness to be on call and deal with production incidents. So let's go back to that MOO timeline real quick and add in some details that might help us understand if this was more successful. See, back in September 2017, only a few months after starting this chaos engineering weekly event, we noticed that people were making rash decisions out of nervousness that there would be, that they wanted to stop the impact to our users. And that was sometimes actually making things worse or hiding the real problem. And so what we did is we added a Slack bot. This provides, at the start of every incident, a list of links which can help us understand what could be the biggest impacts to our users and what we may need to start looking at first for what could be the problem. And this allows people to really focus in on their problems with a cool head rather than trying to make changes quickly and possibly piling on. Also, a few years later, we have now onboarded a bunch of on-call engineers of all different types. So in September 2019, I became an on-call engineer for the first time after running through a few different scenarios over the course of a few different months. And I have to say, being trained in a fairly low risk scenario in a staging outage gave me a lot more confidence to deal with a real outage when I got paged in production for the first time. But it wasn't just new trainees that were coming through this. We also had an experienced engineer who had just come back from paternity leave for a few months, and he was able to re-enter the rotation with confidence after going through a game day. And we've also had other new hires that have more on-call experience go through these as well. It just helps us all build confidence individually and as a team in the way that we deal with an incident in production. And finally, here's an example of a more recent change where we've realized that different people on the team have different levels of experience with our system and know where to check for possible problems and where to check for high-risk issues. And so we've come together and identified a quick list of parts of our system to check on for when we want to communicate about an outage. And so this has been added very recently as a support for our people to feel confident on call. And so I want to share an example of how we got to those successful points. And so I want to dive into what we do on game days. This was previously spoken about as war games, and we've changed that terminology. So in our game days, we have to make sure that we provide the same experience in a pre-production environment as we do in production so that we can build confidence in a real way. So what does the same actually mean? For us, that means that our metrics in Prometheus are the same across staging and production. That includes the alerts that get fired from those metrics, and the dashboards in Grafana are able to be toggled between staging and production data with ease. Our application logs are the same in both environments, and our Kibana setup allows for us to have the same indexes and the same searches. Honeycomb is our tool of choice for events, and that has the same storage across environments. And our PagerDuty alert system allows for the person who's on call during a game day to actually be paged just like they would in production. Finally, our Slack integrations, like that cool calm checklist, is added in staging just the same as in production, just pointed at staging URLs instead of production ones. In reality, staging isn't quite the same, and we know that. And some of these can be solved by technology, but the cost value isn't there for us. So we accept the limitations that there are certain queries that are done on the fly in tools like Kibana and Honeycomb that we can't recreate in staging with ease. There's also the concept of normal traffic. One of the first things you tend to look for when there's an incident is, are we seeing a drop or a rise in one of our statistics, in one of our metrics? And we just don't have a level of orders in staging that would let us do that. So we have to put up with a bit of limitations there. But as I said, we encourage people during this time to stay cool and calm and to use the alerts in the exact same way that you would in production. Clicking on these links take you through to staging URLs to allow for you to be able to check the statistics and the metrics in the same way that you would in production. And so it gives people the chance to experience an outage in the most realistic way possible without user impact. I want to share a second example of how people are supported with these kinds of game days and chaos engineering experiments by actually a different company. So our friends at Gousto have really grown in popularity over the years, and they were looking forward to September 2019 as being a breakout time for them. They were anticipating their highest traffic because what they do is they ship food in boxes along with recipes. And entering in the school year, this was going to be a busy time for people to start this kind of program. The year before, when they had started to grow, they'd broken apart into separate teams. And so they had a separate small platform team and a few different software teams that had operational champions. These are people that are software engineers first and foremost, but they have an interest in resilience, and they kept in close connection with the platform team to learn from them and share their knowledge. But they weren't operational specialists, and neither was the rest of their team. So with this highest level of traffic, would they be ready to support their services in that scenario? Well, they wanted to test themselves at this. And so they did an entire day with all of engineering with a hands-on experiment throughout their platform. And it's really key that this was all day and all of engineering, which is something that not every organization finds the time to invest in. But to them, they were able to build that confidence across all of engineering, and that was worth it. The challenges for the day were created by the platform engineers that had a bit more specialty in the area. And you can see they covered these 4 common areas, including databases, compute, networking, and config. And there were levels of difficulty associated with the different challenges. Each of the teams got a chance to pick one challenge for a certain number of points, and then use their skills in AWS, their own systems, and incident management processes to solve the problem and gain those points. There was a leaderboard, there were prizes. You can imagine it was actually quite a fun day for everyone there. And it was also a heavy learning day. So we talk about the benefit to people as being the ability to self-evaluate readiness to handle the pressure of being on call, of supporting production. And this is the lesson I learned as well when I was doing game days at Moo. To slow down is so key. It can be really hard when you're dealing with an incident for the first time to realize that actually taking a deep breath and waiting is more valuable than taking action right away. And this is what they were able to experience because they felt the pressure of an outage in their environment in a low risk way. They also got to share what they were good at. As engineers were able to solve problems, they were able to share their technology savvy and being able to share the tools in their toolboxes. So while looking in CloudTrail for what did platform do to your service wasn't exactly what platform had in mind when they wanted the teams to understand their technology. But at the same time, viewing CloudTrail for impacts during an outage is absolutely an activity that you may need to do. And this has now been spread among their engineering team to understand it. Finally, they were able to identify what they would need help with. And this is because of the pressure that they had at learning on the go. So this is an individual who learned about auto-scaling groups and DNS and other breadth of information on dealing with outages in their system. They weren't able to learn a depth in these areas during a single day activity, but now they understand what they don't know and can look to train in the right areas for their system. But overall, this is just one step on their journey. And that's the big part about chaos engineering, is it's not something you can just turn on and walk away. There's a lot of introductions that went into this success around lightning talks and trainings. And it also needs to be an ongoing activity because people will learn different things each and every time that they go through the activity, which is why at Moo, we do game days, even with experienced incident commanders, experienced on-call engineers participate in these game day activities, which I will explain a little bit more in the next section. So speaking of the next section, I want to jump on from people to talk about process and how chaos engineering can support it. One of my favorite things about process is this quote about scar tissue. There's this idea that when something goes wrong, people will introduce a new form or a new sign-off process in order to be able to solve that problem and let that issue never happen again. But it doesn't have to be scar tissue. process can also be the exoskeleton that supports you. Only if you do follow that process in such a way that you can design it as you go and intentionally grow it, rather than letting it be reactive based on bad experiences and having it just sit there static. By also talking about chaos engineering on an ongoing basis with our organization, we've been able to share our experiences as the platform team with adjacent teams. And that means both technology and not. It also means our customer services team, for example. And finally, it's identified opportunities for us to lean on tools as support systems. Everything that we do doesn't have to be people focused. Sometimes we can let our tools do the heavy lifting for us. And by focusing on this intentionally, we've been able to do that. So revisiting that Moo timeline again, let's add a few more details. For example, in August 2017, only a couple months after we started working on these weekly game days, we introduced PagerDuty rotas. We realized that having support be done as a best efforts model was just not going to be sustainable for our people. And we wanted to introduce a way for people to know when they needed to be aware of production and when they could be offline. And this gave a lot of structure around what does it mean to be on call. We never had that previously. In a couple months later, it turned out that that schedule wasn't quite working for people, that a week on was actually becoming quite tiresome and quite difficult for people. And so we introduced a new schedule. We changed it to be weekday and weekend. So you pick up on call at 10 a.m. Monday, and you put it down at 10 a.m. Friday, or 10 a.m. Friday to 10 a.m. Monday. And you still have the same number of days per month that you're on call, but they're split up a bit. And so you never get too overwhelmed by what's going on. In addition, in June, we actually had produced an architectural design record, or an ADR, which was part of why that Simian Army tool got rolled out to all the environments. Now, we never got this ADR signed off. We never got buy-in from all of tech leadership or all of tech to run this tool in all the environments. But we were able to codify why it was important to us to run these experiments and the value that technology would get from it. And we've been able to lean on those writings in more recent time as we revisited this as well. Finally, that incident management process that I talked about being introduced when we introduced the PagerDuty rotas, well, it took a while, but it started to really formalize. And by July of 2018, we actually codified it in a Git repository that is public for all of tech to understand and to share. It's even got fun icons for it too, and different personalities. So you can see what each of the roles during an incident will be handling. So let's go into some examples of how we got here, how we got these benefits. And I want to dive into game days a little bit further, because it's not just about the technology staying the same. It's also about how the organizational and social environments need to keep the same processes and same pressures. So on a game day, we have a whole bunch of people involved. This is not about one person being put on the spotlight, can they solve the problem? So let's walk through some of these different roles. The organizer is the person who makes sure the day goes on. They do comms to the teams about when an environment might be in bad shape. They also make sure that everyone in this group knows what their role is. And in particular, they work with the game master, who is going to be the person who actually introduces the fault into the system. This person might need to practice or make sure they understand what fault they're introducing in order to make sure that the environment has some sort of an outage at the beginning of our game day. When that outage gets raised, whether it be with an automated alert or a manual, the incident commander gets paged in PagerDuty. As we talked about, the technology stays the same. They will acknowledge that issue, and they'll start communicating and identifying what could be going wrong. As they find they might need some help, they can pull in a firefighter if they feel the need, and this person can help them with the technology side of things. They can go run queries, they can go check out servers, things like that maybe takes a bit of deep dive when the incident commander is trying to keep the high level understanding. Meanwhile, sometimes there are engineers who mean well, but actually are causing a bit of havoc during an incident, right? They might be unaware of that need to slow down and understand what's going on before you take action. And they can actually be unhelpful in the process, whether it be because they don't understand our process or because they are unsure about the system that's down and taking actions that make things worse. And so we often have an engineer who's working in that role, imitating experiences that we've had in the past. In addition, we have a CTO and customer service representative from our own team imitating the needs of those people, making sure that they get communication when they need it and how they need it at their level of depth. So what does an actual game day look like? Well, the last time I was organizer, this is how we kicked off. We said it's 5:15 p.m. on an unseasonably warm March day, and we've just finished our company all hands, and all are headed to the office party when. And it can seem a bit silly to do things like this, to say what the weather was like, to say what time of day it was, things like that. But this is all part of what sets us up for testing our process at different times. Does the same thing work at 2 a.m. that works at 2 p.m.? Does it need to? How do we want to handle that? The example here being at 5:15 after an all hands means that people are probably getting on their way. They're headed out to the pub or they're headed home on the commute. And so if you need to pull people in for help, you should do it quickly because otherwise they might become less available. And that is something that you need to think about when you're the incident commander, you're the on-call engineer. So let's just jump in a little bit further into the process of being on call. Here is the game's beginning. So in our outage test channel, which mimics our outage channel, we have run a slash incident, which is a slash command in Slack, where you can add a write-up about what you're seeing that's funny. And the customer service rep says that there's a problem with designing products. And so our incident commander is paged and acknowledges it. Upon acknowledging, we actually generate a new Slack channel, which has a unique identifying ID on it and allows for us to make sure all communications about this incident are in a single location. This is all a part of our process for an incident and all mimics exactly what happens in production. When we pop into that now outage specific channel, we're able to see the cool, calm checklist, just like's been shared earlier. This reminds people about what is most important to our site and where to start to look for that. And again, all of these are for staging so we can use them for real during this game day. But let's look at how an engineer might hold up to the challenges. Here is a real example from one of our game days. We have an unhelpful engineer indicating that they're going to start taking some actions and they need an incident commander maybe to say, whoa, slow down. We've got a CTO who's worried about impacts to SLAs and needs to have an understanding of, if this is going to be a problem. Customer service is popping in to keep an eye on what's going on. And we've got the incident commander giving comms about what's going on throughout the system. An example of an unhelpful engineer is tons of links out and tons of adding the incident commander, getting a lot of their attention away. If they don't know what they're targeting, that can be quite distracting. And so it's a fine line between firefighting and unhelpful engineer. So it can be quite fun for us. But we spend at most 45 minutes doing this. And that would include raising the incident, answering the page, triaging what is going on, communicating about it, and hopefully mitigating it. But at the end of 45 minutes, the game master can revert whatever they did to the environment if needed. Because what we don't want is that environment to then be broken forever and for a long time for our users, for our other software devs. The reason we keep to 45 minutes is because we want to grow our process intentionally rather than artificially design it. And by having a 15-minute debrief, we're able to really dig into what went well and what were challenges that we could get improved. An example of an issue that came up recently was, how do we decide what's worth checking on? And then how do we cascade that info? Different engineers had different understandings of the way the system worked and what was kind of mimicking each other, where you only had to check one to know that both worked, and what were independent pathways or independent use cases that needed to be checked independently. And so what we decided as a team is we spent that retrospective talking about what areas of the application we would need to check that would be important for our stakeholders. And one of our team members put together this as a Slack message to send into the main outage channel that most of the organization follows to understand the impact to the site. It's able to clearly identify who's impacted at that time and how. And this also helps the on-call engineer who's worrying about all the things about being broken to make sure that they're ticking all the boxes and making sure that they understand the scope of the problem. Because understanding that this impacts one or many of these sections can really impact where the problem is. So by doing all this in public, by having our game days in public channels that mimic those in the production, we're able to share our experiences with other teams. The roles and responsibilities doc is in public, and people have looked at that and followed along with our test game days as well. The channels allow anybody to join, and we also even schedule game days with other teams. I would say not always, but we try and do that on a regular basis. And because for them to understand what's happening with our incident commanding when their application is broken is really helpful when it comes down to production. So I want to talk a bit more about game days with other teams, but I'm going to do that in the next section, which is how we're going to talk about platform or your tech. And this is the section that most people focus on when they talk about chaos engineering. They think it's all about the tech, but it's actually left last for a reason. And that's because it's only one part, and that people and process make up so much of the benefits of chaos engineering. And I think it needs airtime. But of course, platform benefits too. And that's because our systems can often be a black box, and we really need to understand what's going on in them. We can build confidence in them when it's warranted. We can identify the weak points that we do need to focus on and improve. And we really can look into and investigate where we may want to spend our engineering efforts to mitigate risks. So looking at our timeline, one really big piece of testing our platform was around adding chaos engineering with a team, running these experiments with other teams, which we didn't really start until the end of last year. And this has been a really big improvement for us. So I want to talk a bit about this fulfill team that we did a game day with. So our fulfill crew was getting a bit confident. They're a great team, and they're at the end of the chain, which handles the shipping of our products. And so they're really sure of what their domain is. They have a really close relationship with our warehouses because that's their customers. And while they're not on call, because only the platform team is at Moo, they might as well be. They're very aware when there's an outage associated with their platform, and they're able to help us fix it very quickly. So they wanted to test themselves a bit, just like Gousto did. And so we asked, what do you worry about? And they did still have worries. They worry about S3 connectivity, slow third parties, losing of certain instances, and setup data being unavailable. These are all reasonable risks. But we didn't stop there with what they were worried about, because humans love to backfill information. We always say, oh, I knew that, I knew that. But by forcing the team to come up with a hypothesis of what would happen in each of these scenarios, we were able to make sure that they deepened their current understanding, because it involved a bit of research to decide what they thought would happen, and actually some disagreements within the team that had to be sorted out first. And it set up an opportunity to learn so that we wouldn't backfill that information, so that we would observe what really happened and see how we could fix things or improve things in the future. So we went through each of these risks and we added our expectations. For this first one, we thought, this is just going to be an alert that gets triggered. It's pretty easy. It's an on-off alert. Is S3 accessible? This next one has a bit more of a complicated alert. It has some logic around duration and third parties and percentage of people impacted, but still we expect an alert. Finally, we have some resilience in place with auto-scaling groups. So when we start losing an instance, we would expect that to bring back and to be self-healing. But if it doesn't, then an alert would trigger. So we expect this one to solve itself, but if not, an alert. And finally, it's okay to actually have no idea. Just be clear about that. So in this case, they have some setup data called shipping options, and they just really weren't sure if that didn't exist exactly how bad the system would be. And they wanted to see so they could prioritize whether or not they wanted to make it more resilient for that data. And so by going through that game day, this was an hour across 3 scenarios, what did we learn? Well, we built confidence. Our self-healing with auto-scaling groups worked. And while this was introduced by the platform team, the software team now saw it work and had confidence that it would in the future. So it no longer needed to be a fear for them. We were able to identify weak points because it turned out that that complicated alert wasn't calculating correctly. And so now they had a specific task they could add to their backlog and improve very soon so that they would know if anything went wrong with their third parties faster and therefore be able to help our customer service team and our customers. And finally, turns out if you lose your setup data, it can be quite painful. But now they know exactly how painful, and they're able to identify and prioritize spending time on backups and testing those backups and making sure it's harder to lose this data. So this was things that would help them prioritize against other requirements in their backlog. So a wrap up, which I guess is, put another way, is we looked into some of these learnings and we had to look back and see them. And so I hope that you can kind of take some of these forward and apply them to your organization sooner. So first, it's always think about your outcomes. It's not just technology that benefits from chaos engineering. It's your people and your process as well. And make sure you're thinking about that and about which of those three areas you most want to focus on, because you don't want to think that you had a problem or think you didn't get the benefit when actually you got a lot of benefit, which is exactly what happened with us at Moo. It takes a lot of energy, but getting the right people in the room really matters. It took us a long time to engage with customer service and other software teams when we were doing these game days and doing these experiments. But by bringing them involved, we've learned from them how they perceive our activities during an outage, and we've been able to grow. We've also been able to help them be more helpful during an outage because they understand the processes that are going on. So get them in the room, have them help you come up with scenarios that matter to them, and build your process along with them. Build in time for retrospectives and improvements. That 15 minutes of every hour of our game day is the thing that actually makes us better. And so making sure to spend time on that every single time that you do an experiment is really key, and prioritize the outcomes associated with it as well. Keep in mind that chaos does not equal random. It can be random, but that's only after you've proven to yourself and to your organization that you can handle that. Start by creating fault injection in a very specific way in order to build confidence in your systems and in yourselves. And finally, lean on exploratory skills already within your team and your organization. You have people who do user acceptance testing already. You have testers who do exploratory testing. You have operations engineers who validate their systems. These people can be creative about how they would break a system and use them to identify risks that you may want to inject and therefore validate your system can handle. You've got a lot of tools in your toolbox already. You don't need a professional chaos engineering person to come in and make them work. And so just the final word on this is that a lot of technology today has been repackaged with new names, and chaos engineering is no different. It's built on the back of some really long-term skill sets like operational acceptance testing, which is known as OAT, or exploratory testing. And that is something that we have to accept, and we can also use to be able to look at other experiences in history and get ideas for how to apply chaos engineering today. But the thing is repackaging doesn't have to mean that it's not valuable. You don't have to throw this away because it's a fad word. The new term chaos engineering is actually driving a cross-disciplinary conversation. It's bringing together the people who ran operational acceptance testing and the people who ran exploratory tests, with both of them saying, but we already do this. And now they're having a conversation about how to learn together. And that is a huge part of bringing in new terminology and crossing these boundaries. So I really hope you too can join across your organization to look at how faults in your system, unknown unknowns, can be handled better by your people, by your processes, and by your platform. Thank you so much for spending time to talk about chaos engineering with me today. I really hope we can keep the conversation going. So feel free to reach out to me on Twitter or elsewhere, and definitely do your own research. There's lots of information out there from vendors like Gremlin and Chaos IQ, as well as tons of other people that are implementing chaos engineering in their workspaces. So this is something that can be applied to organizations, both big and small, and I hope you can use it at yours as well to support your people, processes, and platform. Thanks so much.